All right, so here's the deal. All right, in Algebra 2, you have to know your Algebra 1 factoring methods. Okay, so the reason I gave you guys this sheet, this factoring method sheet, is so we can recognize some of these methods as we're looking at our practice test today, which we're going to do together.
Yes.
Okay, and so we got to start seeing, you know, when you factor, you're trying to create the intercept form or the part form of a polynomial. Okay, so the first method that you're always going to use is called the GCF method, greatest common factor. Okay, so what that means is, like, if I have any polynomial, all right, you always pull out the greatest common factor between the numbers first. So notice 4, 12, and 8 all have 4 in common. So 4 goes out front. Okay? And then between the letters, the highest number of m's you can pull out is just 1. So that's why this number in front of the parenthesis is called your greatest common factor. Okay? Now I always tell kids, the way to check is if I divide 4m out of the first term, notice I'm left with 4 divided by 4, just 1. M4 divided by m is m cubed, is left inside. Think about there's 3 m's left inside. Okay? Notice in the second term, 12 divided by 4 is 3. Right? M squared divided by m, 1 left over. That's your second term. And then the third term, 8 divided by 4 is 2. And m divided by m cancels. So the way to check your answer is to multiply back through. Notice if I multiply back through, you're going to get 4m to the 4th. Listen up, please. Okay? What's 4m times negative 3m? Yep. And then what's 4m times 2? 8m. So notice the factored form is like undoing the distributive property. You're creating the parts that when multiplied through create what you started with. Okay? So the first method that you want to be aware of is this GCF method, guys. You always do that first, no matter what you see. Any type you see. Okay? Now, for now, I'm going to skip this grouping method. We're going to do this when we get into higher order polys, okay? But that's on your list as a reference. Now, from Tuesday's lesson, you did this method. General trinomials, okay? When A equals 1. Okay? So what I mean by that is, notice you got a trinomial with no GCF. Guys, pay attention. Okay? So notice if there's a 1 out front and there's no GCF, you take the C value, the factors of C that make a negative 11 in the middle. That's the easiest way to look at it, right? So what factors of 30 make a negative 11? So it'll be 5 and 6. And they both would have to be what sign? Negatives. So notice you're just going to create these two parts. So that method is called a general trinomial factoring method. Okay, so that's simple. On yesterday's lesson, or actually Wednesday's, excuse me, you did this method, divide and slide. So I wanted you to watch the lesson video, take your own notes, and see how to apply this method. Okay? So what you do on this method is when you have a general try, when A doesn't equal 1. So notice here's an example right here. You see how there's no GCF, and what's the number out front? 5, right? So it's not 1 anymore. So now I have to recognize I have to use the divide and slide method to factor this type. Okay? So all you do is you take the 5 times 6 and make 30 over here. So now the leading coefficient is 1. And then you actually factor that like you normally would, right? So what factors of 30 make 17 in the middle? 15 times 2. So that's why x squared splits to x and x. 30 splits to 15 times 2. Notice the signs would have to be positive to get a plus 17 in the middle. Okay? Now what you have to remember with this method is that you don't stop there though. You have to divide the last terms by what you multiplied by in the beginning. So I divide by 5. The same thing here is take the last term divided by 5. Okay. So does 5 come out of 15 evenly? So that's why that one became x plus 3. Okay. Notice the 5 doesn't come out of 2 evenly, right? So what did the video tell you to do yesterday? So what do we do with this 5? You slide it in front of the x. So you have to remember that if it doesn't divide evenly, you slide it in front of the x. So that's why it became 5x plus 2 for the second one. So we have to recognize when we use this method, guys. All right, that's when that a doesn't equal 1. Okay? All right, another common Algebra 1 method for factoring is this one right here. It's called difference of squares. Okay? So anytime you see a difference of perfect squares, all you do is square root both terms. So what's the square root of x squared? X and x, right? What's the square root of 81? 9 and 9. All right, and then one has to be positive and the other has to be negative. So the factored form looks like that. All right, so all that requires, guys, is you just know your perfect squares from middle school. As long as you know your perfect squares, at least up to 12 squared, you're probably going to be pretty good with recognizing that. Okay? And then the last Algebra 1 method that you want to be aware of is this perfect square trinomial one, when this pops up. Okay? So what I mean by that is, like, you're going to get a trinomial, and you're going to notice that sometimes if there's no GCF, sometimes the first and last terms might be perfect squares. Okay? So to check that it's a perfect square trinomial, there's a special pattern you got to see. All right? So all you do is square root the ends first. Okay? So what's the square root of 121x squared? 11x. What's the square root of 4? 2. So you put them together, and then you double it. Double the product of those. Okay? So what's 2 times 22x? What's 2 times 22x? 44x is in the middle. So anytime you double the product of their square roots, and you get that middle term, that's how you can check to see it's a perfect square trinomial. Okay? So what I mean by that is the factored form of those actually look like this. You're actually going to get 2 11x minus 2's. So if you ever factor it with the general trie method and you notice that it's the same thing, then you know it's a perfect square trie. So that's important to pick up on. Okay? So what we're going to do is I have a sample quiz we're going to go through. And I want to make sure we're recognizing all 6 of, basically the 5 main methods. The grouping one we'll skip for now when we do this, okay? So this is an important recognition skill from Algebra 1. All right? So here we go. Problem 1. Everybody pay attention, guys. We're going to go right through these skills. You got to see this, right? All right. Which of the following is not in standard form? Letter C. So some of these are going to be super easy, super quick recognition skills. Standard means go high from low from the exponents. Okay? All right, problem 2. Which of the following is not a difference of squares? Good. See, the rest of these guys are difference of perfect squares. Good. All right, problem 3. Which of the following can be factored? Good. C is the only one. Now, I want you guys to see why, though. Okay? So, looking at C, that's a difference of perfect squares, so that factors to x plus 4, x minus 4. Okay? Now, looking at A, can you do anything to that one? Is there a GCF you could pop out? No, right? What about B? No. And what about D? Yeah, that's a trie, but there's no factors of 1 that make 43 in the middle. So you can already recognize that C is the only one that's factorable. Okay? So these are important skills to talk about. So we're recognizing some of these terms, right? So number 4. Which of the following is not a perfect square trinomial? So let's check it with method 6. So we want to make sure we're recognizing those perfect square tries, right? So here we go. On the first one, general try, no GCF. First and last terms are perfect squares. So if you square root the ends, let's go ahead and show that. So you're going to get x and 1. And then all you do is double the product of those. So what's 2 times 1x? What's 2 times 1x, guys? 2x. So notice that's your middle term. That's a perfect square try off the list. Okay, check the next one then, right? There's no GCF, but the first and last terms are perfect squares. So you square root the ends, and you're going to get x and what? What's the square root of 4, guys? 2, right? What's double 2x? 4x in the middle. That's a perfect square try. Okay, then you check the next one, right? Now, even though there is a GCF here, you can check to see if it's a perfect square try with that method. Okay, so here we go. What's the square root of 4x squared? 2x. What's the square root of 16? 4. So if you double the product of those, what's 2 times 8x? Is the middle term 16? That one's not a perfect square trinomial. That's an important skill, guys. Sometimes they're going to want to check that, right? So obviously the next one wouldn't be either. Okay? All right, number 5. Which of the following is not a binomial? Which one's not a binomial? D. That's a trinomial. Okay? Number 6. Which of the following is not a trinomial? A. That's a binomial. Very good. Okay? All right, here we go. So now let's apply our methods. Okay? Zoe, you paying attention there? All right, here we go. Problem 7. First thing we always look for is a GCF. Okay? Is there a GCF other than 1? No. All right, you got 5 methods on your list. What method is this one? That's a difference of what? Good. So all that is method 5. So all you do is you square root both. You put 2 binomials down, right? You square root the first term. Those are 3 x's. Just write it twice. The square root of 9x is 3x. You just write it twice. Okay? What's the square root of 1? Write it twice. Okay? One has to be positive and the other has to be negative. All right, now keep in mind, the way you know this is right is if you FOIL it back in your head, it's going to go back to what you started with. Okay, so what I mean by that is, let's check with the FOIL method. What's 3x times 3x? 9x squared. Outer terms. 3x times negative 1. Negative 3x. Inner terms. 1 times 3x. Positive 3x. They cancel. The last terms, 1 times negative 1. Negative 1. There you go. Okay? Alright, so let's jot that down. This is method 5. So you want to keep that list handy, guys, when you do these, right? So, alright, problem 8. You're creating the parts, right? Is there a GCF between the numbers? Yes. What number divides out of both of those? 5. So all you do is pop a 5 out front from the numbers. Okay? Now look at the letters. What's the highest number of x's you can pop out? X. Just one x. So 5x goes out front. That's considered your greatest common factor, GCF. Okay? So we always do that first, guys. No matter what type you see, you look for that GCF. Okay? So here we go. What's 10 divided by 5? What's x squared divided by x? X. Okay. What's 35 divided by 5? 7. What's x divided by x? Cancels. That's your answer. So all we did was which method on this one? Method which one, guys? 1. This is method 1. Very good. Okay. So that's method 1. All right. Problem 9. We're going to create the parts. Okay. So notice there's no GCF between the numbers, but the number out front is not 1. Good. So I have to recognize out of my list, this is which method? Divide and slide. This is method 4. Very good. Okay. So, and this came from Wednesday's lesson. So all you do is take 2 times 5 and rewrite it. X squared minus 3x plus 10. Now the challenge you're going to have here is when you look at this problem, you want the factors of 10 that make negative 3 in the middle. So what would that be? Well, let's try it, right? So you know it's x squared splits to x and x. 5 and 2 make 3 in the middle. The problem with that is the only way to get negative 3 in the middle is negative 5 plus 2. Here's the problem with that answer. What's negative 5 times 2 become? Negative 10. So that's not going to work. So what do we argue? Good. So this would be unfactorable. Even though we applied the right method, even though we applied the divide and slide method, we notice it was unfactorable past this point. So you just say the original problem's unfactorable then. That would have to be a negative 10. Okay. All right. Problem 10. Okay. A general try. Good. 1 out front. Are there any factors of 64 that make negative 16? 8. Good. So all you do is you split it up into x and x, 8 and 8, both minuses. Now, if they're both the same, what specific method really is this? Which one really is this, guys? Method 6. It's really it's a method 6 problem. That's a perfect square trinomial. Even though it's a general try, you could do it with the general try method. Okay, good. All right, number 11. Declan, do you have a GCF? Any common factors you could pull out? No, right? So what method would I use here? Good. This is a divide and slide problem. All you do is take 6 times 20, x squared minus 7x minus 120. All right, on your own, finish it. Use the divide and slide method to get your 2 parts. All right, so I want to just see that we remember that method. Okay? Right now, I just want to make sure. So remember, yeah, you got to find factors of 120 that get you that negative 7 in the middle. You might want to make a list on the top. Calculator to maybe divide out some factors. Okay? You got to find those magic numbers. Use the calculator to divide out factors of 120. Right, you have calculators. So you want factors of 120 that make a negative 7 right in the middle. Okay? Again, just start dividing out numbers. Start with 1, 2, 3, 4, so forth. Make a list. Right?
What are you doing?
So you need factors of 120 that make negative 7.
Bro, you're stepping into my life. No, this is what you're talking about. It's a joke, and I ain't even make the weed. You made it. Bring it low. Okay. Not happening. Yep.
Yeah, if sometimes it helps, guys, to just make a little list on the side, right? Factors of 1 to 1, and then you'll find the magic number. And then it'll produce the fraction. Yeah, 15, or the 15. That's the magic number. All right. So here's what I would do. I'd take this general try, and just, if you didn't know the factors right away, just make a list, right? So 1 times 120, 2 times 60, 3 times 40 going to 120, 4 times 30, 5 times 24, 6 times 20, right? And then 8 times what? 15. Why do I have to stop right there? Why do I have to stop at 8 and 15? Are you gonna get 7 from 8 and 15? Yes. So all you do is you split it up. 15 and 8. All right. The only way to get -7 from those two numbers is -15 plus 8. Now, a lot of times what students will stop there, so you got to be careful, right? So then what you do is you divide the last terms by what you multiplied, by 6. Okay? And this is something you really got to pay attention to, guys. Look at it. Before you slide, always reduce the fractions. Okay? So what comes out of 15 and 6? 3. So if I take a 3 out of the bottom, I got 2. A 3 at the top, I got 5. So now I can do what with this 2 on the bottom? So what could I do now? Slide it. That's what was in the video. In the lesson video, this was clearly shown. So I want to make sure you guys pick that up. So notice you get 2x minus 5 from the first one. Okay? Now, you see how 6 doesn't come out of 8, but you can reduce this fraction first. All right? So take a 2 out of each. What am I left on the bottom with? 3 and 4. So now 3 doesn't come out of 4. So where does the 3 end up? In front of the x, right? So what's the other one going to be? 3x plus 4. That's your final answer. So notice we did method 4. This was an Algebra 1 factoring method to make sure we do that type of problem correct. Okay, so good. What do we do at number 12? Good, pull out a 4 first. So put a 4 out front. So now you got 3 terms inside that are divided out with 4. So we did method 1 first. We put a GCF out front. Okay. So who can help me? What's left inside, guys, if I divide out 4? X squared plus 8 divided by 4? 2x plus 4 divided by 4? 1. All right. Chat, what would I do with this try inside? Because I'm not done yet. You don't need to distribute, guys. You're undistributing when you're factoring, okay? So I pull a 4 out front. That's your GCF. Notice the try inside is a perfect square try. So what's that factor to? Those are perfect squares on the ends, right? So you get x and x. And then what's the square root of 1? 1 and 1. What would the signs have to be? Plus and plus. Very good. That's your answer. So we did method 6. Method 1 first, method 6 second. With that try inside there. So you got to be careful there to see that, okay? So like I said, we need to perfect these methods a little bit, right? So like look at number 13. Cameron, what pops out of these 3? Well, they all have x's in them. So what's the highest number of x's? Good. So all you do is pull an x squared out front. That's called your greatest common factor. Always do that first, guys. Right? So notice with the three terms, I could show what's left inside. Okay? So Blake, tell us what's left inside here. 5x to the what power? Second. Right? What's the next term? 8x. Good. And then what's the next one? Minus 4. Good. GCF first. Excellent. Now, when you get to this step, you may have something inside that parenthesis that's another algebra method. So that yellow trinomial is now which method? Divide and slide. So now you got to apply divide and slide to the yellow thing. All right, so now I have to recognize that, okay, even though I did GCF first, this thing is a divide and slide problem. So you take 5 times 4, rewrite it. X squared minus 8x minus 20. Okay, what factors of 20 make 8? And actually, this is a plus, not a minus. I got to make sure the 8's positive. That's a plus, yeah. So make sure it's a plus. So what is it, guys? 10 and 2, right? So let's split that up into x and x from the x squared. The only way to get 8 in the middle from the factors of 20 is 10 and 2. No. So how do you get an 8, guys? Positive 10 minus 2. Okay? And then don't forget to divide the last terms by what? Divide by what? By 5, right? Okay, so here we go. What's the first one become? What's this one become, guys? 10 divided by 5? 2. Okay. Does 5 come out of 2 evenly? No. So where does it go? In front of the x. So it's 5x minus 2. So the final answer is these two parts with the x squared out front. So we did 2 methods, method 1 and 4, to get our final result. Okay? And I'll tell you right now, you got to know these guys. This is going to be like a prerequisite skill. Before we start getting into higher polynomials, we got to know these methods. Okay? So we'll get there. All right, let's skip 14 for now. I just want to do a few more and just recognize a few things, and then we'll let you guys look at some other looks on this. Okay? All right, look at number 15. Notice there's no GCF. So what method would I use? 5 out front, guys. What method? Divide and slide. See, I got to go right to my, you got to know these methods like real quick, fast and quick, right? So notice I'll get x squared plus 2x plus 35. But here's the issue you're going to see with this, though, right? Are there any factors of 35 that make a plus 2? So some of you guys might argue 7 and 5. Here's the problem with this. The only way to get a plus 2 from those two numbers is positive 7 minus 5. But you'll also notice that the last terms have to make a plus 35, and they don't. So what we say is this is unfactorable. Okay? Guys, stop talking, please. Okay? So, all right. Number 16 is important to talk about, because this is a math practice skill. Okay? See, when I look at those two terms, the first thing I notice is there is a GCF. What number divides out of both of those? 2. The reason you want to pull a negative 2 out and not a positive 2 is because anytime you pull a GCF out, you want the first term to be plus. That's a common algebra mistake. All right, so that's why I'm going to pop a negative 2 out of both of these. So when I do that, notice the first term is now going to be what? 25x squared. It's a positive term. Okay? So what's 128 divided by negative 2? Minus 64. See, the first thing I did was pull a GCF out, method 1. And then we also notice is this is a difference of squares. So David, what's that, the yellow thing factor to then? So you're going to get 5x and 5x from the first term. And what's the square root of 64? 8. And then what sign would they have to be to get a to cancel out, guys? Positive and negative. Good. So that's actually your final answer. So notice we did GCF method. That was number 5. Okay. All right. How about this? Let's finish with these two real quick. Give me that factored forms of 17 and 18. All right. Let's go ahead and get those factored right. And identify your methods right away. Okay. And good to go. Okay. So they had to be 12. Try to get both of them done and then just write them out down on the side. Right from that way. It's got to pick factors of 24 that makes it 10. Good to go. Get them right? Yeah. Okay, so these should be real quick and easy ones, right? So, yeah, look at 17, right? General try, no GCF. What factors of 24 make 10? 12 and 2. All right, the only way to get plus 10 is positive 12 minus 2. You're done with that one. Now, the reason you can't do 6 and 4, and this is something I want to point out here, this is a common mistake. The only way to get 10 is plus plus, but the last term's multiplied to a positive 24. So it's not those two. So we know it's going to be these two. So all that was general try, guys. That was method 3. Okay? All right, the last one. All you did is pop out a 2, hopefully. So there's your GCF, method 1. And then notice inside the parentheses, that's a difference of squares. So what would that one factor to? X and X, and then what? Plus 2 minus 2. So then we did method 5 with that one. Okay?